Hi. Welcome to the lot sizes topic in SAP IBP explainer video series from GitaCloud. This series is aimed at supply planners and any other IBP practitioners. This is part 4. It explains the following lot sizing procedures: static periods of supply with average demand, and target periods of customer demand. We will talk about dynamic periods of supply in part 5. Static periods of supply is superior to safety stock in general, but it may struggle in case of high forecast error, as it plans based on specific demands within the coverage span. Planners can use a variation of the static periods of supply, which plans forward cover based on average demand, to mitigate the impact of high forecast error. We know that average error across periods is usually lower than error within specific periods, hence this helps plan forward cover better. Average demand is computed across a horizon separate from the coverage span. We will continue the static periods of supply example from part 3 video of the lot sizes topic, but run with average demand this time. Note the lot sizing procedure value of 4, static periods of supply with average demand. Also note that number of periods for average demand is set to 4, which makes IBP compute average demand across the next 4 subsequent periods. Please refer to the part 2 video of lot sizes topic to understand the rest of the master data. We have included it here as a reference. Let's build on the example from the part 3 video in lot sizes series, where we explained how infinite supply heuristics uses subperiods to define coverage span. Note the coverage span is effectively 2 weeks from week 29 to 33, as target subperiods of supply is 14, with 7 subperiods in each week. 14 divided by 7 equals 2 weeks of coverage span. Let's focus on week 31 to understand the planning results. Number of subsequent periods for average demand is set to 4, hence we take the average of demand from weeks 32 to 35. This is 129 units, as explained on the right side of your screen. Additional lot sizing procedure demand is based on a coverage span of 2 weeks, hence 2 times the average demand of 129, gives us a value of 258 units. Net demand is calculated as before. We add inventory target of 100, to the dependent demand of 74, and the additional lot sizing demand of 258. We then subtract 314 units of projected stock from week 30, to arrive at the net demand of 118 units. Let's also review results from week 35 to understand how coverage span makes a difference to the net demand. Note the coverage span is effectively 3 weeks from week 34 onwards, as target subperiods of supply is 21, with 7 subperiods in each week. You can see that the average of demand from weeks 36 to 39 is 217 units. Additional lot sizing procedure demand is now based on a coverage span of 3 weeks, hence 3 times the average demand of 217, gives us a value of 651 units. Net demand is calculated as before. We add inventory target of 100, to the dependent demand of 162, and the additional lot sizing demand of 651. We then subtract 685 units of projected stock from week 34, to arrive at the net demand of 228 units. Another option planners have is to plan forward cover only for the customer demand. Coverage span key figures such as target periods of supply, and subperiods, do not apply in this case. Lot sizing procedure needs to be set to 0, lot for lot, to run with this lot sizing approach. Let's review planning results from infinite supply heuristic. Target periods for customer demand key figure is set to cover for the next 5 weeks of customer demand, while ignoring any dependent location or production demands. Let's focus on week 31 again. Demand for the next 5 periods, week 32 to 36, is 75 units. Additional lot sizing demand is shown as 0, given the lot for lot procedure. Net demand is calculated as before. We add inventory target of 100, to the dependent demand of 74, and the customer demand of 75 units. We then subtract 170 units of projected stock from week 30, to arrive at the net demand of 79 units. Note that dependent location demand and dependent production demands exist, but have been ignored from a forward cover perspective. This is despite the master data attributes to ignore the dependent location and production demands not set to ignore these demands. In conclusion, static periods of supply lot sizing procedure supports planning with average demand, which helps to mitigate safety stock imbalances, in cases of high forecast error. Planners can plan forward cover just to support customer demands, and ignore dependent location or production demands. See Part 5 video to understand dynamic periods of supply lot sizing procedure. You can find this and all other IBP Explainer series videos at GitaCloud website or GitaCloud YouTube channel. SAP IBP has a wide range of demand or supply planning features that your planners may be interested in. GitaCloud can help you understand how IBP can model your specific planning problems and how that adds value to your planners. You can reach us with a quick email to connect@GitaCloud.com. Hope you enjoyed this video. Please like and share if you did. Have a great week.